morning to all of you. So we are discussing the chapter laws of motions of your uh, class 11 standard syllabus. We have discussed Newton's first law, Newton's second law, as well as Newton's third law, which proof and different types of applications and examples of Newton's laws. We're going to discuss today about a topic that is also one type of force. This is your impulse and impulsive force. So we'll discuss about impulse. Impulse. Very important topic to know it. So what is basically impulses? Impulses generally it is one type of force, you can say, or sometimes we say this impulse as impulsive force also. So impulse is nothing but impulse is just, as you can say, that impulse is equal to, if you want to write the impulse, that this is equal to, impulse is equal to, you can write that force into time. Am I clear? Force into time. This force is also sometime can be told as average force. Average force into time. That is how we express the impulse. Understand? So this is what impulse is. That means if a force is applied for a very short interval of time, then that force is also known as impulsive force. You can have so many examples of impulse. The best example of impulse you can see when in the time of cricket matches, when a fielder catches the ball, once he want to catch the ball and once the ball strikes the hands, he just takes the hands backward like that. Once you catch the ball, you just bring the hand little bit towards you. That means once the fielder is catching the ball, he brings his hand towards him so that he can grab the ball very nicely. So that ball has got inside the hand and ball get tightly captured by his hand. But if the ball is coming towards you and fielder is giving, if it is giving like that, or if it is applying, if he is not bringing his hand back, then what happened? Most probably he will not be able to catch the ball. Am I clear? So these are one most important example, a very easy example of impulse. What is that? I told you that catching a ball or the action by the fielders, action of hand represented by the fielder during the time of catching the ball in the field, that you can say as the examples of impulse. So what happens once you apply the force for a very short amount of time? Once you apply the force for a very short interval of time, then there will be a change of momentum. The momentum of the ball will be changed somehow. Hence, the impulse can also be expressed as the change of momentum, the rate of change of momentum. We can prove this one mathematically. But we should not go to that much of complexity. So we have to just distinguish, remember that impulse is equal to average force into time. And in so many books or so many author has written this is as force into time. So that's no problem. Impulse is equal to force into time. It's a product of average force and time. So in this case, I have also given the examples of impulse. Apart from that, how we can prove these things, that the impulse is also the change of momentum? We can use the Newton's second law in this regard. If we use Newton's second law, we can come to know how the impulse is related to the rate of change of momentum. So if I apply it, we know that according to Newton's second law, that F is equal to dP by dt. These things we know, that the applied external force is equal to rate of change of momentum. So this things F is equal to dP by dt. Now in this case, if I find out the dP is equal to, we'll write F dt. If I follow this definition, so this is going to be your average force. That means average force into dt. I have cross multiplied. Now if I integrate both sides, suppose I am integrating both sides. If I integrate both sides, then what will happen? That in this case, there will be upper limit and lower limit. Suppose this is time, so time will be integrated. So when time t was 0, suppose momentum was p1, because this dp means what? The change in momentum, and we can also say that dp is nothing but this is p2 minus p1. That will be your change of momentum. So this is what, this is from Newton's second law. As you can say, F is equal to dp by dt. So here I have taken dp out, so it is average force into dt. I told you that this is average force as I am following this definition of impulse. That is average force into time. So once I have integrated them, so when time t was 0, the momentum was p1, and when time becomes t, the momentum becomes p2. Understand now? When time was 0, momentum is p1. When time is t, momentum is your p2. These things I think you have understood. Now if I break these things, what will happen? In this case, I can directly write p2 minus p1 is equal to, so what will remain in this case? This is your F. This is F. That means if I integrate, this is going to be your F. This is average force, or F if I say. And if you integrate this t, so what will become in this case for this t? And once I break them, so if I show you by breaking this, is that is integration of dt will become itself t. Since you know that if I break this thing like that, this is dt, and upper limit t and lower limit 0. So t minus 0 is equal to t. So it is force into time. Have you got it? So after breaking these things, we have got this much of equation, that p2 minus p1 is equal to F into t. Now what is F into t? Force into time. What you can find by force into time? That from this equation, F is, as you can see, that F is equal to what? dp by dt. F is equal to dp by dt. Now in this case, if I multiply force and time, I can get the moment. I can get the what? This is F into t, force and time. This is force into time. Force into time is itself impulse. So I can write now that p2 minus p1 is equal to average force into time. That is going to be your impulse. That is I. Hence I can write that impulse. Therefore, impulse I is equal to p2 minus p1. You can write as del p. So, hence it is proved mathematically that impulse is nothing but it is change of momentum. That is your del p. Though basically you can say that definitions of impulse will be force, average force in the time. When you apply some amount of force for a very small interval of time, then that force will be known as impulse. Is that clear? And once you apply the force for some amount of time to an object, the momentum of the object will be changed. And that thing can also be determined as the impulse. As I am telling you, that impulse is also change of momentum, and we can prove this is mathematically in this way. We can prove from the Newton's second law, that is F is equal to dp by dt, rate of change of momentum. Then I have integrated them with respect to their upper limit, lower limit, all these things. When time t was 0, momentum was p1. When time t became t, momentum becomes t2. So all these things has come after putting, after calculating all these things, we have come to a decision that p2 minus p1, that is nothing but change of momentum, will be equal to multiplication of average force and time, which will give you the impulse. So impulse is also stated as the change of momentum. I have given examples of it. that when the cricketers, fielders catch the ball, during the catching the ball by fielder, fielder brings the hands back to him so that he can catch the ball nicely, or so that the ball comes to his hands and the ball is got grabbed nicely by the fielder. Okay, so this is all about impulse. Now if we look at some couple of more things about impulse, that SI unit of impulse, you can write SI unit of impulse is, what is the SI unit of impulse? So it is very simple, that force part is Newton and this is time, this is your second, Newton second. Newton second is the SI unit for the impulse. That is force, for force it is Newton, and for time that is your second. So Newton second is going to be your SI unit for the impulse. Most importantly, I am going to show you also the dimensions of impulse for a special case. You'll come to know after finding out these things. So what is the dimensions of impulse? So if I go to find out the dimensions of impulse, what is I is equal to? This is F. F, this is force and this is time. So you can find that in case of force, the dimension of force, as you know, the dimensions of force is, anybody knows the dimension of force? F, we have already studied in the first chapter of dimensional analysis how to find the dimensions of a particular term. So this is MLT inverse 2. MLT inverse 2. This is going to be for force. Am I clear? Next, it will become again, we have the time for this time. So we'll have MLT inverse 1. Most significantly, the dimensions of impulse and dimensions of momentum are same. Dimensions of momentum also, as you can see, this is MLT inverse 1. Okay, as you know what is momentum? Momentum was P is equal to nothing but product of mass and velocity. So if you go to find out the dimensions of momentum, this is going to be MLT inverse 1. Hence, dimensions of momentum and dimensions of impulse are same. From that point of view also we can be confirmed that impulse is nothing but it is change of momentum. When momentum will be changed, when some amount of force will be applied to a particular object for some amount of time. I hope you have cleared these small topics, but very important. Next class we'll discuss about conservation of momentum. Till then, thank you so much.